Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM Arts students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth, one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.
Hi everybody, welcome back to another episode of Space on Earth. My name is Taylor.
I'm Tulsi.
And today we're going to be talking to you guys about binary stars. And so we're going to give you guys just some information about what exactly they are, how they work, different types of binary stars, and why they matter in astronomy. So for those of you who don't know or haven't heard of them, binary stars are when two stars work in one solar system and they orbit each other. And so, yeah, Tulsi, do you kind of want to go into a bit further detail about what exactly is a binary star system?
Yeah, sure. Like you said, it's when two stars are orbiting a common center of mass that they share, called a barycenter. Basically, the gravity keeps them bound together so they're orbiting and don't stray from that. And actually, roughly half of all of the star systems in our galaxy are binaries or multiples, which is when there's more than two stars orbiting that center of gravity. And there are other types of binary star systems as well. Do you want to touch on that, Taylor?
Yeah, totally. So let's get into the different types of binary star systems. So we can kind of break them into different categories. So first we have visual binaries. And these can be seen as two separate stars through a telescope. So a good example of this is Alberio, which is in the constellation Cygnus. And then we also have spectroscopic binaries, which are too close to each other to distinguish visually. So looking through a telescope, we would only really see one star. However, we can detect this in other ways using Doppler shifts and spectral lines. And we've talked a bit about this in past episodes. So maybe if you've been listening to us for a while, you're kind of familiar with what that is. Doppler effect is basically, and we can see this kind of in the way we receive color from light, is that when something is moving away from us, the waves appear to be more stretched out. And then when something is moving towards us, those waves appear to be more closely packed together. So that's kind of how we can detect them, even when we can't see two separate stars. We also have eclipsing binaries, which is when one star is passing in front of the other. And the way that we can detect this is we see these regular dips in brightness when observing what seems like it could just be one star. And that usually can suggest that maybe it's a binary system. And then we also have astrometric binaries, where only one star is visible, but it kind of wobbles back and forth. We're seeing some movement with that star, which suggests that there's some unseen companion or other body of mass that we can't see and don't know about. So those are some kind of different types that we see, as well as ways that we detect them. And then when we actually get into the physics of it, they actually work in a pretty interesting way. Tulsi, do you want to talk about that?
Basically, every binary system revolves, like I said, around a shared center of gravity. If the stars have equal mass, then the center sits halfway between them. But if one star is heavier, then the center shifts closer to it, which makes it move less. If the stars are very close, the orbit can take only hours. but depending on how far it is, it can take up to years.
That's super cool. So that's one way that they really interact with one another. Like you said, Tulsi, is that it depends on the star's mass, it depends on their distance from each other, and that can really, kind of cause different ways that they work. And so you might be thinking, like, well, what really happens between two stars when they're orbiting around the same point? So, one thing that can happen is a mass transfer, which is when one star kind of steals material from the other. And we'll see this just like with gravity and how mass gets kind of pulled towards a certain center of gravity. And so, every now and then, with two stars in a binary system, we see that one starts getting bigger than the other, which is really cool. And then we also have accretion disks, which can happen where gas is spiraling around a star or a compact object within a binary system. And then there's some exotic phenomena that we see every now and then with them. So one of them is, different novas and stuff like that, which is a very sudden brightening of an object that we're seeing through a telescope or through any imaging. And then we also have a type 1a supernova that can happen with binary star systems. And we use information like this for measuring universe expansion. And then in really extreme systems, which means that both of these stars are, really high in mass, we could see either a neutron star or even cooler, black hole pairs. And so there's definitely a lot of ways that these kind of interact. And like I said a bit earlier, sometimes we use this for measuring universe expansion, but that's not the only way that we use information about binary stars. Tulsi, how else do astronomers use this information?
Well, one of the biggest ways that binary stars help us is they're one of the only direct ways that we can use to measure stellar mass. And stellar mass basically determines the amount of material and the weight of it. But for single stars, you can't just weigh them. So binary systems solve that.
Yeah, so binary systems are really helpful just because of the way that their orbits work is slightly different from a normal star, and we can see that interaction a bit better when there's like two large objects that we can see and we can see how they interact. So we can kind of measure the mass of those stars in that way.
They also have a big role in cosmic events like supernova and gravitational waves.
Yeah, totally. And like I said earlier, they are helpful in stellar evolution theories. Like I mentioned, we can use them to kind of measure expansion in the universe. Plus, they're really important in exoplanet studies, because we can study how planets exist in binary systems and how they're impacted by that. So there's a lot of really cool information we can get. And then there's also some fun stuff that we know about binary star systems. So, like Tulsi said, there's a lot of variation in the way that they orbit each other. And like she said, some of them only take hours to complete a full orbit, which is kind of cool to think about if you think about, two giant stars spinning around each other that fast. It's just really neat. And one fun fact about binary systems, and for any of you who listened to our last episode, if you haven't, I recommend checking that one out. It's definitely a fun one. One of the first really mentions, or at least one that's like well known, of two stars existing in one system comes from some sci-fi films. Primary example is Star Wars. You see they're on this planet Tatooine, and there's kind of this iconic shot of seeing two suns in the sky. And when this was originally put out, that was like a really far out, less practical theory. And now we have the science and math to prove that that could really happen. So, yeah, some basically kind of a recap of everything that we've learned today is that not only are binary stars really dynamic and cool, but they're way more common than you might think, and they really help us understand the universe in fundamental ways.
Well, that's all for today. Thank you guys so much for listening and supporting us. If you want to know more about our program or have any questions, you can reach out to us at stemarts.com. Once again, thank you all for joining us. I'm Tulsi,
And I'm Taylor.
and we'll see you next time.